Let's have a look at this integral from 0 to 1 of sine of log of 1 over x times x to b times minus x to a over log x dx. A and b are both positive. So I'm looking at this part, just this part. So that looks to me like the definite integral. If I just treat x as a constant, it looks like definite integral. That is equal to log of x to t evaluated from a to b. Replace t with b. Take their difference. So meaning this has to be the antiderivative of some function. Which function's antiderivative is this? Let's just take the derivative of this. Let's find out. X to t log x. X as a constant. So that is called log x e to the log of x to the t. T times log of x. Derivative. Copy down the constant log of x. Using the chain rule, a constant of t is log x times e to the, this whole thing. But this whole thing is x to t. Log x to t. So meaning 1 of x to t, one of its antiderivatives is this. So this is really the so meaning this is integrand. From a to b, the integrand x to t dt. So this integral can be written into 0 to 1 sine of log of 1 over x. Integral from a to b, x to t dt, this part, then dx. So this is in fact a double integral. First, integrate with respect to t, then integrate with respect to x. And also we know that a and b are both positive, dt, t also has to be positive. So therefore the integral, first we can take this constant inside here, because right now I'm treating x as a constant. Then we can switch the order of integration. Outside first, I'm going to do from a to b. Inside, I'm going to do from 0 to 1. This is taken inside. Sine of log of 1 over x times x to t. Like I said, first let's do dx. Then I'm going to do dt. dt. In this case, it's legal to switch. So this time I'm going to look at this. So log of 1 over x. Perhaps I should let this equal to y. So e to the y is equal to 1 over x. So x is equal to its reciprocal, e to the minus y. So dx is equal to negative e to the negative y, dy. And also x to the t this time is equal to e to the negative t times y, t this time is a constant. So this time the integral I should be equal to, first copy down 0 from a to b, then from also change the boundaries. X used to be 0. When x is equal to 0, y is equal to log of positive infinity. When x is equal to 1, y is equal to log 1, that's 0. Inside the integrand, we have sine y times x to the t times dx, This times that. We have a negative, negative, get rid of negative, change the boundaries. 0 to positive infinity. Then it's e to the negative of t plus 1 times y dy. And then dy, then dt, right? Then dt. So this time I'm letting, perhaps I should let e to this part equal to u and this part equal to dv, right? Integral by parts. U is equal to e to the negative of t plus 1 times y dv sine y dy. So du is equal to negative of t plus 1 times e to the negative of t plus 1 times y dy. And v, right, antiderivative, negative cosine y. So the integral, perhaps let's call the inside integral I naught. Right, this I naught. So I naught is equal to uv, right, first of all uv, negative cosine y times e to the negative of t plus 1 times y from 0 to positive infinity minus integral from 0 to positive infinity times v du, negative gone, t plus 1 constant, right, t plus 1 times cosine y e to the negative of t plus 1 times y dy. Right. So that is equal to positive, like I said, t is positive, right, from this boundary, right, these boundaries, both positive, right? So t plus 1 also positive. Negative of t plus 1 is negative, right? So negative times positive infinity, we have negative infinity. E to the negative infinity approaching 0, right? Cosine bounded, so altogether approaching 0. So 0 minus 0 goes in here, right? So e to the 0, 1. Cosine 0, 1, we have negative 1. So we have 0 minus negative 1. So 0 plus 1, we have 1. Here, what do we have? Minus t plus 1, constant, taken out. Here, we still have 0 to positive infinity. Cosine y, e to the negative of t plus 1 times y dy. So let me see. So again, I'm going to let this equal to u, this equal to dv. U is e to the negative of t plus 1 times y dv cosine y dy. So du is negative t plus 1 times e to the negative of t plus 1 times y dy. V is equal to sine y, of course. And I naught is equal to 1 minus t plus 1 times quantity uv e to the negative of t plus 1 y from 0 to positive infinity minus v du negative becomes plus t plus 1 taken out, constant. then integral from 0 to positive infinity sine y e to the negative t plus 1 times y dy bracket. And this integral, this is exactly this integral, right? I naught, right? Exactly the same. So I naught is equal to 1 minus. So let me just positive infinity, right, goes in here. Like I said, e to the negative infinity approaching 0. And 0 times bound is still 0. So 0 goes into here. I have 1 times 0, 0. So this is gone. This is gone. So all I have is 1 minus t plus 1. Quantity is square. Quantity is square, right, times this. Times I naught. So I naught is equal to 1 over 1 plus t plus 1 quantity square. So I naught turns out to be this. So I'm calculating integral from a to b. I naught is this. That's 1 over 1 plus t plus 1 quantity square dt. Right, this time dt. So this obviously arctangent t plus 1, right, evaluated from a to b. And that is arctangent b plus 1 minus arctangent a plus 1. And we're done. And if we want to further simplify, then we can say that we can let 10 if we let arctangent, so if we let tangent alpha equal to b plus 1, then we can say alpha must be equal to arctangent b plus 1, right, according to definition, right? So tangent beta is equal to a plus 1, then beta must be equal to arctangent of a plus 1. Okay. So tangent alpha minus beta is equal to tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. Right. In other words, that is equal to tangent alpha minus tangent beta. B plus 1 minus a plus 1. 1 gone. B minus a. 1 plus b plus 1 times a plus 1. Right? So in other words, arctangent, according to the definition, arctangent of b minus a over 1 plus b plus 1 times a plus 1 must be equal to the angle, right? Alpha minus beta. Right. So this is the angle alpha. This is the angle beta. Alpha minus beta, right, perhaps can be written in this arctangent